Can't trust you no more.
Psychologically abused since I was a kid, believing your stories, the things that you did. Now I'm asking for my money back. I have it tallied up, 800,768 fiat dollars. Gave you my trust, followed your way. Now I see the deceit on display. NASA, you've been lying to me. Lies and deceit, it's all I see. NASA, you've been lying to me. But deception's a game you played every day. Lies and deceit, it's all I see. NASA, you've been lying to me with your fake streams and false reality. NASA, you've betrayed my trust with your fake streams. I stopped being blind. Admit you're unjust. Lies. Since I was a kid, you fed me lies, stories and fables. Now I realize, meant for the masses, to be force-fed to the blind. NASA, you've been lying to me.
Roundtable number 80.
And false reality.
Tonight, Shane's going to be doing a Prezi on the Great Turtle in the Sky. Shane, whenever you're ready, sir.
Nice. Thanks, Alan. Welcome, everyone. We only got a couple people here, so if you have questions or contributions, throw them out. We're going to be looking at the eclipse cycle, right? So the big long eclipse cycle, the basic building block of the lunar cycle, the overall great cycle, I guess we can call it, the super long 651-year cycle. But we're going to start with the path of the sun and the moon and the concept of time, because we're going to be using the eclipse chronometer, actually. There, my stream is up. There we go. We're going to be using the eclipse chronometer, which is using the cycle of the eclipse to date the world and date our civilization. We're going to be looking at the complicated Saros cycle from NASA. We're going to break it down into its simplest form. We're going to not separate it into lunar and solar cycles so that we can see the actual cycle in the sky. So it's my position and opinion that this knowledge was ancient and has since been forgotten and or occulted and then directly weaponized against us. Right? I think not being able to read the sky clock is a significant disadvantage. It puts us in a position in which we can be manipulated. I think it's pivotal that we understand the cyclical nature of the sky, right? But before we can understand the macro, we got to understand the micro. And the lunar cycle would be the smallest part of the macro cycle of the larger collection of cycles in the sky. So that's where we're going to start. We would know that, by their appearance in the heavens, the celestial objects sort of mark periods of time for all to know. And as the sky functions as this clock, but most of us have forgotten how to read it. Here pictured, we have a Germanic calendar, I think. Yeah, Germanic calendar, we complete with the seasons, the months, the lunar cycles, and really everything. This is how it should be, right? A wheel of time with all cohesive elements sort of splayed out. Around the side, you have the months named. Inside, we have the constellation. You can tell it's got the Great Dipper, which is there comparing to their seasons over here. The lunar cycle is going around and matching. It's exactly when this is going to match. You don't see the intercalary days or the days they need to offset to match the solar and the lunar. This all kind of works cohesively together. But we're going to start with the path of the sun and the moon, right? Typically, this two dynamic system of the sun and the moon causes every important system on the earth, essentially. It's responsible for heat, the seasons, it's responsible for the tides, it's responsible for all the electromagnetism, it's everything, right? So here's the path of the moon, typically portrayed, and you can see the sinusoidal sort of pattern as it moves in between the tropics. Now, the moon goes a little bit past the tropics, so it doesn't exactly follow the path of the tropics, but it more or less does what the sun does in a year in a month. Of course, the sun makes the same path. And again, this is the path that they'll show you most typically. It's the sinusoidal pattern on a Mercator or an equirectangular or a millimeter equal area or a cylindrical equal area projection. All of these projection types of the square sort of 1-inch grid lines. This is the maps that they'll show it to you on. And this is the path that most of us are accustomed to seeing on timeanddate.com, etc. But as most of us know, this is the identical path, just projected on the AE projection and to give you a semblance of the sun's and the moon's path over the flat Earth. No, or over the flattened out graticule, right? Because this is not what this represents. This represents the graticule still, not the flat Earth. But this is what the sun's pattern looks like when you can see all the continents. It migrates from within each tropic, right? And the moon goes a little bit past and a little bit out. If you were to look at the same path on the globe orthographic projection, it looks like this, right? You still got it splayed out between the tropics, and it still makes its path in between the tropics. So again, all of this data has been the same. None of it has been different. We started with the perfect predictable pattern of the sun and the moon, and we haven't changed it this whole time. Each one of these is showing the same exact path. And it's these paths that we're going to be looking at, and we're going to be looking at when and where they intersect in a 3D model to produce the conditions for eclipses. Look at this sort of illustration over here. We have the sun and the spinning constellations. So we have the Gleason's map with the land masses, and above it we have the known constellations projected on a projection with the sun moving in between it. Now you can kind of see how the sun is moving in between constellations. Here, you can definitely see how it's moving in constellations. Ignore the script here, we're just looking at the pictures. But here's the analemma of the sun, its annual path, and you can see it moving in between these constellations as it progresses through the year. We also know the sun does its sort of dance from tropic to tropic, and it changes its height, as shown here. Changes its height, and it goes lower out to the Tropic of Capricorn than it does from the Tropic of Cancer. And we know over here is a good depiction of how that would be seen to each observer in your local azimuthal grid. And as it goes from higher to lower, it makes these celestial arcs, arc and antarc, depending on your latitude. I think we all know that. Let's see here. So the path of the sun and the moon, as we just looked at, and this is again the Mercator sinusoidal projection depiction of it, can be modeled in terms of frequencies. Right, the tides specifically are formed with semi-diurnal frequencies. They do constituents and tidal constituents, and they do harmonic analysis, and using in basis forms of interpolation, they're able to predict tides and tidal ebbs and flows based on the frequency that which they've converted on the path of the sun and the moon. So the path and the sun and the moon are compared to sound frequencies and then have constructive and destructive interference. That's how the tides work. So that's a dynamic system, again, caused by the path of the sun and the moon. If we were to look at it, say the equation of time, since we're going to be using it as a chronometer, and we're going to be looking at the art of chronology, and we're going to try and date our civilization based on the cycles in the sky, we should understand the equation of time over here. Of course, there are explanation for the effect of the obliquity of the ecliptic and orbital eccentricity we can sort of ignore because we're just looking at the way that the sun's path is depicted. And again, sinusoidal, right over here, with respect to frequency. And here's again the depiction of the same phenomena as it makes its traveling throughout the year from tropic to tropic. And this is what it looks like to the observer. And here's, of course, a mathematical sort of symbol, right? We have the sine wave going in the background. And again, we're just getting a feel for the path of the sun and the moon and how they are the dynamic cause of most systems on the Earth. So if we look at the history, well, the historicity of solar and lunar cycles as measures of time, it's useful because it's what was done in the Bible. And as we'll get to in a little bit, the entire Bible we can date with a lunar calendar, which means if we stick to the 13 months, 28 days we see on the back of our turtle shell, then we can date the dates for the Bible, and we can count in chronological sequential order backwards to get an accurate dating for the world. So they do this other treatment with the Hebrew calendar and the solar calendar. They have this treatment of intercalary days, and they have the insertion of Sabbath days, and this works with the chronology of the 7-day week. So it's a historical consistency with this pattern, and that's what we're going to be using to more accurately date the world. And if we weren't for this, we wouldn't be able to do this. So typically we know that older societies had lunar calendars. We have what's known as the solar calendar today, and our Gregorian calendar. But the lunar calendar was definitely based on the cycles of the moon. The solar would be the seasons, and they have lunar solar calendars, which sort of combine the two with intercalary insertions to try to make the offset the difference. But we'll get into all that because we'd have to understand the sky clock, right? We'd have to understand that we can look at the sky and tell the time of year, the time of day, and the time of month by looking at the luminaries. Of course, the sun telling us the time of day. But is it rising? Is it setting? Is it at the zenith? Is it high noon? Is it in the morning? We can tell all that from looking at the sun. If we were to follow a lunar calendar, we could tell the day of the month by the phase of the moon directly, right? Each month beginning with new moon, ending with in the middle of with full moon, and at the end with whatever this one is. I forget, waxing crescent, I think. And then the sun's path within the stars, within the constellations, will tell you the time of the year or the actual month. We can, I have a video for that. So if you were to speed up this clock here, right, with the sun and the moon and the constellations, what I'm doing is jumping ahead by month. And if you jump ahead by month, you can see the sun will appear to be in a different constellation. And this is what I mean by using the constellations to track the seasons, because the path of the sun, where the sun appears in the zodiac for anyone, can tell you the specific time of year. Now that's going to vary with what type of calendar you're using, whether you're using a solar, lunar, or lunar solar calendar. But chronologically, you can get which month it is by knowing where the sun is in which zodiac. Most of astrology, in fact, is based on this, right? You get the sun sign, things like that. So everyone is aware that this is a chronological sort of a timepiece that you can track by knowing where the sun is in each constellation. The other part is, of course, the moon. So the speed of the sun here, it looks like it's going backwards, right? Because we're jumping a month ahead. So this is what we'll see later when we model eclipses. When we jump forward, the sun will appear to move backwards. And that's an effect of the sun traversing through the zodiac. And you only see that effect when you move quickly through the months, right? So if you take a series of time snapshots that progress the sun at the same point, it will appear as if it's moving backwards, right? But it's really not. So we'll start with the other calendars we were talking about, right? It's hard to count what month it is when you're trying to use the Gregorian calendar transferred from the Julian calendar, accommodating for daylight savings time. Don't forget the leap year, switching from lunar to solar, and then back to the Roman times. It's almost impossible to chronologically date anything tracking the change in systems throughout our history. There's been so many chronological changes through our timekeeping method that any sort of tracking has become almost impossible. But I think that's by design. There's been changes to sort of muddy the water and make history hard to track. So we're going to watch this quick little 3-minute video of this dude talking about how many months should there be, because this is the video I saw like 2 years ago, which first set me off thinking about calendars, eclipse cycles, and chronology.
Our calendar is not quite right. We're supposed to have 13 months of 28 days, with one day, the day of resurrection, Easter, as a neutral day. That's our 365 days. We've actually got 13 constellations, not 12. This same calendar is very close to the Mayan calendar, but it's also very close to several ancient Sanskrit calendars. What does sept mean? 7. I thought that was the 9th month. What does oct mean? What does nov mean? What does dec mean? It's supposed to be the 7th, 8th, 9th, and 10th month. Jan is 11. Feb is 12. March is 13. April is our first month. Babies are born in the spring, the 1st of April, Easter. This is the start of our new year. This is the start of spring, when the flowers start coming up, the grass starts coming up, the trees start leafing out, the babies are born. That's the first day. Our neutral day, day 1, the day we rest and celebrate the resurrection, the new beginning, the beginning of Christ. April is month 1. And then we lost a month in there. Where is it? What's it called?
Right. So that's the first time I saw anyone talk about how our calendar wasn't right, and the first time I started thinking about it. And what he's talking about is a 13-month calendar, specifically divided into 28 days. There's already an implementation of it called the abysmal calendar, and sure, that links with this, but it doesn't actually follow the lunar cycle, right? The lunar cycle for the month is 29.5 days, so it's not synced with the lunar cycle at all. It is specific in timekeeping, and it has its advantages, right? But it does have a drift to it that would make it not useful to track lunar cycles at all. So when you're trying to use the sky clock, that's not really what we want. There are other implementations of a 13-month calendar, right? So it is a form of this, and it does rely on the 7-day week. And if you look at it, it makes more sense historically and how we used to date things and how you think about it. Sorry, was that Ken? Oh, no worries. So they have another concept of it based on the 7-day week where things would make more sense. Right, so 7 days is a week, 14 days is a fortnight, a specific in common metric of time. 28 days is 2 fortnights. 91 days would be a quarter. 182 days would be a semester. So then you have 364 days equaling exactly 52 weeks, which is 26 fortnights or 13 months divided into 4 quarters equaling 2 semesters. So there's some nice symmetry there. So it does have its advantages. However, if you're trying to track the time, the day of the month based on the moon phases, you would need something that coincides with the phases of the moon. As we were talking about earlier, you have the famous turtle shell with, every turtle has 13 months and 28 days around the outer shell. And it is true that the old ancient civilizations used lunar calendars, right? They use calendars that would be, this is what this is, but 13 moon cycles and 27 to 29 days. A true lunar calendar would be oscillating months of 29 and 30 days. And only that way would you average 29.5 days. And only that way would you sync with a lunar cycle. So that would be the answer to this. This is a neat meme though. I really like this. The turtle clock is going to be useful later because it's the only way we can count the number of eclipse cycles to use as a chronometer to coincide with dates to match the astronomical lines of time. So another disadvantage of the 13-month year here, like we said, it does divide evenly into 28 equal days, and it has one holiday, and it works with units of time. It keeps everything synonymous with the week, and it heavily relies on the 7-day week, which has never been broken. The problem, though, with that calendar and with our calendar is the drift. Right? Here's a nice image of the Gregorian calendar that we use today. Number of days over here, 30, between 28 and 30. You get 29, 30, 31. All the months have different days, and you can see that the problem is the phases of the moon drift. They're not always at the same time of the month. They're at different times, and in fact, they drift forward one day each month all the way through. So it is no middle of the month is always the full moon. New moon isn't always at the beginning. In fact, with this calendar, you would invert the position by the end of the year. So if the first of the month was a full moon, by the end it would be a new moon, right? The complete opposite. If we were to talk about a lunar solar calendar, which would combine both of those two, then you'd have the intercalary days to make it match. So it resolves the mismatch between the 365 solar year and the 29.5 sort of moon phase lunar year. So again, this keeps the synchronicity with the lunar cycle because they keep 30 and 29 month days. We'll look at an example of that later, or right after this actually. And the solar calendar again would be 13 times 28 in one leap day. So that's 28 day fixed months, shorter than the synodic month, which is the moon phase. And then you have the lunar solar, which is what we're talking about. It's the Hebrew and Chinese. The lunar is Islamic. We're going to look at an Islamic calendar in just a minute, but lunar solar typically is Hebrew and Chinese. And we're going to be using the Hebrew lunar solar calendar to date it because it's going to have 20, 28, and 29. Let's look over here. Right. So we had lunar and the solar and the lunar solar. This is the differences between the three. One would be synced to the moon phases. One is synced to the solar year. And this one offsets with both, right? 29 to 30 days, 29 to 30 days, 28 to 31. This is what we have. What happens is the lunar solar drifts between the seasons. So it maintains its alignment with the lunar cycle, but drifts between seasons. So March won't always be spring, right? That's going to be a problem for most people. Solar calendar aligned with the seasons, but not with the lunar cycle. And then aligned with the both, but with the leap months. They insert leap months at the end of every lunar cycle. We'll look into that in a little bit. So again, lunar calendars prioritize lunar cycles, but lose sync with seasons. Solar calendars align with seasons, but ignore the moon. And lunar solar calendars blend both, using intercalary and leap days to maintain. So real quick, we have an example of an Islamic calendar, which is a specific lunar calendar. Note the absolute oscillation between 30 and 29 days. Actually, I think it goes up and down. 30 and 29 days. And they have offsets. So they do this because it aligns with their religious cycles specifically. Easier for them. Right, and it's hard to synchronize with other calendars, though. At any given point on Earth, there's something like 300 types of calendars in use. So any large-scale program to date things chronologically is really hard to synchronize all of the calendars in use and then to get the proper date range from any specific shared date. What we would need is something like the Metonic cycle, which is actually going to link the lunar and the solar calendar together. So what it is the 19-year period that aligns the lunar phases with the solar year, and enabling lunar solar calendars to maintain the seasonal and lunar synchronization. So this is the exact answer to the problem that we were just having, right? We just ran a little Hegelian dialectic on you, presented a problem, and then gave you my prefab solution. The Metonic cycle is going to be how they solve the intercalary and leap years and synchronize the lunar and the solar calendar, right? And this is supposedly attributed to this dude named Meton of Athens, popularized this back in before they had calendars, etc. Most of our dating, though, is going to be based on this book. We're going to be using this book a lot. This is pretty much the basis for the breakdown of the eclipse cycle and also the astronomical lines of time. It's by a dude named J.B. Dimbleby, who is best friends with Alex Gleason, right? Alex Gleason, who does the Gleason's map, who wrote a book also called Is the Earth a Globe? Is the Bible from Heaven? Right about the same time. This was published in 1879, right about the same time that Gleason published his book. Story has it that these two chaps were friends, and even though Dimbleby is a globularist, obviously he's a creationist, and he had some things in line with his buddy Gleason, and they were trying to convince each other of different things. So Gleason's book is geared at convincing someone just like Dimbleby that the Earth isn't a sphere and is in fact a flat plane. And Dimbleby's book is actually a well-known, well-researched, and well-accredited book of chronology. He references the greats in here. He gets credit from, I think, the Astronomical Society, the Royal Society, all the good ones. So I think his preface here says, by authoritatively to maintain and make known the consensus of the science of time, thus definitely and correctly obtained, to remove the ignorance which exists among mankind through an imperfect knowledge of the elementary character of time. So that's a very grandiose way of saying some corrupt people have been lying to you, and I want to give you the truth. That's how I read that paragraph, right? It says, to remove the ignorance which exists among mankind through an imperfect knowledge of the elementary character of time. So real quick, one of the lines of time that he uses to analyze historical works and the world with is intercalary period. So what we were just talking about, the interplay of the solar and the lunar calendar and the need for these insertions of offsets to make it match is how specifically he knows which dates are which and how he has tracked things throughout the Bible. Because historically, the days of Scripture, or the days of Scripture history, which were employed to lengthen or shorten the lunar years to the solar period, were 77 days at the end of each solar cycle of 7 lunar years during the continuance of the antediluvian cycle. So he goes through the actual cycle here and which calendar he's going to be using. And only through the intercalary insertion periods is he able to date all these, because they're always inserted at the same time. Thus, you can use that to find references in the sky, and then use the cycle of the eclipses to align up with other historical events and get 5 types of corroboration in order to actually date that event, right? So again, we went over this. Solar calendars have leap years and leap days to make it sync. And we know that we have every 4 years we insert a day, right? And that's our sort of intercalary period. And other lunar solar calendars use the Metonic cycle, and the other lunar calendars have their own sort of offset. So this is one of the prefaces from his book, and he says, he goes into the meaning of the solar cycle, but he says the calendar that he's going to use, the years are lunar, and therefore the months have alternately 30 and 29 days, because the arrangement is observed by the Jews, Turks, and Chinese, and has the new moon on the first day of each month, right? Because the moon travels around the earth in 29.5 days. So the moon was like a great clock in the sky, new at the beginning and full in the middle of the month. So he's definitely and clearly using the lunar calendar here, or at least the turtle clock in the sky. You need to have this offset. You need to be able to match the lunar cycle over here of 29.5 days. Otherwise, you won't be able to interpret the cycles in the sky, and you won't be able to date them to any historical significance. So we're going to go into what a Saros cycle is and how that repeats for the moon. But first, we're going to take a look at what the ecliptic is and how we observe it for the sun and how it impacts eclipses.
So when we talk about
sound,
the
right?
ecliptic, we're talking about the tilt at which the sun appears to each observer, right? Because it does its progression annually from season to season, and it moves from tropic to tropic. It actually gets higher and lower, and it is that path that appears to us to move within a 23.4 degree gap of our azimuthal grid, or our local alt-az grid. So if you look at what the sun does, we typically think that they're moving around and they're intersecting. But when we're talking about eclipses, we're talking about much more than the frequency at which these two circles intersect, because they're also in 3D on a different path. The sun's at this slight ecliptic path, about a 5 degree tilt, and the moon's a little bit off of that, as you can see. So because of this intersection, the rate at which they actually intersect is much less, right? So otherwise you'd have an eclipse every month. Ecliptic is the sun's tilt from a base level that we observe in our grid. It goes from here to here. This is the 23.4 degree gap that we notice, that we observe in the sky, right? From the sun's precession. But if we look up to what the sun is actually doing, as it goes from tropic to tropic, it's going higher and lower. See, it starts off really high in the Tropic of Cancer, goes really low to go out to the Tropic of Capricorn over here. So what that looks like to us, of course, the sun progressing in this band, right, of above and beyond. So the observation is this, and then they contrive it back to get a ecliptic at which the whole solar system is actually tilted at to make sense of the sun's angle and parallel light rays. So they take this observation of this 23.4 degree band with which the sun migrates, and then they created a whole model that said the solar system is actually tilted at this angle, and that all light is parallel, and it's actually at a balanced flat axis, but the whole solar system is tilted 23 point to whatever. So when we're talking about eclipses, we're talking about when these two intersect. These would be the nodes, which we can see here. These are the ascending and descending nodes. This is commonly what gets misconstrued as Rahu and Ketu. And these are the intersection points at which they actually intersect. What the sun's ecliptic was compared to the moon's track, how they're at different inclines, and how those separate inclines mean that the intersection is much less frequent when talking about the eclipse cycle, the lunar cycle, and the great astronomical year.
Right, so the incline, the difference with which the sun orbital plane intersects the moon's orbital plane, the height difference is what creates the timing difference of the intersection, which is why you don't have an eclipse every month. So these four things are actually the solstice and the equinox nodes, but there's also the lunar nodes, which is going to be right over here. This is going to be the rising and the ascending nodes, and this is the knot, right? And these are actually the 2 points at which the sun and the moon's path intersect, at which eclipses occur. If the sun and the moon intersect at the ascending node, there's a lunar eclipse. If there's at the descending node, it's a solar eclipse, which is the craziest part. And we're going to go through that animation over here, right? So the great intersection knots move slowly in the opposite direction of the sun and the moon. And again, we have the optically backwards traveling sun that we described earlier. So we're going to watch one intersection. It's going to happen in real time with this model to give us an idea of what we're talking about here. So if the sun and the moon meet at the same knot, the solar eclipse happens. If they're at different knots, lunar eclipse. Right? So if the sun and the moon are at the same spot, solar eclipse. If the sun's over here and the moon's over here, lunar eclipse. Okay, boom, and apparent occultation. There it is. So that's one eclipse. We're going to be talking about how series and types and character of eclipses repeat, where they repeat, what's the rate at which they repeat, and how often do they repeat. Let's see here. Did I lose my present mode? I did. Present. And it's back. Cool. So we're going to try and demystify the Saros cycle, because a lot of people talk about it and they don't actually know what it means or how it's used, or more accurately, how NASA has abused this to obfuscate and confuse the masses, which is what my position is. So they're calling it a Saros cycle would be a team of repeating sister eclipses that repeat the phases of the moon exactly after 235 synodic months. So a series of eclipses that are separated by one Saros is called the Saros series, and they go every 18 years or so, and that's why they're so far apart, and that's why they span hundreds of years, because the dual nature and spread of time between eclipses. So this is sort of sinister on NASA's part. What NASA does is split all eclipses, and they call it the canon of eclipses, into lunar and then solar. And a Saros cycle will be a whole series of lunar eclipses. So that lunar eclipse, and then 18 years, that lunar eclipse again, and then 18 years, that lunar eclipse. That's what a Saros cycle is. That's not the cycle that we're going to use. We're going to use, like, say, between now and 40 years from now, how many eclipses will occur, and there'll be between 2 and 3 each year, and we're going to go through sequentially and chronologically that cycle and how that cycle repeats. This cycle is useless and just it's the craziest way to do it. To separate lunar and solar, first of all, is the most insidious part of this, because there's no way you'll understand how the cycle works together interconnectively unless you keep them together. If you separate them, you'll have no idea how the cycle works. So the exact period of this Saros is 6,585 days, which is about 18 years. We'll get into this in a little bit. But what happens is there's 3 periodicities of the moon that have to align for an eclipse to occur. So there's 3 periods. The first one we talked about a lot, the synodic month, also commonly called the lunar phase, is this 29.53 days. This is from new moon to new moon. So what this is the phases of the moon, the apparent luminosity of the moon as it goes from super bright to completely invisible, and then back to super bright again, right? That's what this periodicity describes. And again, 29.5 days. The animalastic month is perigee to perigee, which just means as part of its elliptical orbit, the one furthest point to the furthest point, right? 27.5 days. Draconic month is node to node. So when the time it passes from that intersection point where it meets the sun till it comes all the way back around and it comes back to that point where it meets the sun again. So the sun doesn't have to be there, but the moon's progression from that point all the way around to that point again is this draconic month, which is 27.2 days. Notice that they're all a little bit different, but they're all very close, and they all align every 18 years to create an eclipse. So an eclipse will happen when all three of these things align again. And essentially it's defined as this, right? So 223 synodic months, 241 draconic months, which is again moon's orbital nodes, 239 animalastic months, which is the elliptical orbit perigee to perigee. And so eclipses separated by this amount of time, 18 years, 11 days, 8 hours, is called, so they share identical geometry. So they occur at the same lunar node, the same distance from Earth. However, the position, because of the westward shifting sidereal rotation, and because of this 8-hour difference right here, the position at which this duplicate eclipse will occur will be shifted by 127 degrees longitude each cycle. So it moves about 1/3 around the Earth because of the 8-hour difference in the time that it last occurred. So the cyclical nature of it means it comes right back around, but because it's not an exact amount of days, it has a 3rd day offset that puts it in a different position. And this is going to be super important for how we're going to understand the main cycle. I think I had a video. There we go.
So the path of the celestial bodies is important because the varying speeds at which they travel is the catalyst for almost every pattern we recognize here on Earth. The dynamic dance of the sun and the moon and the interharmonics there are responsible for nearly everything that we have on Earth, seasons, tides, you name it. All of this is essentially just a product of the harmonic dance between the sun and the moon. The smallest building block of the greater celestial cycle in the sky is the lunar cycle. So to dissect that first, so there are 3 other types of cycles, also known as lunar periodicities. And these 3 cycles and the harmonics between them determine when, where, and how solar and lunar eclipses occur. The Saros actually arises from a natural harmony between 3 of these periodicities. So the synodic month, the animalastic month, and the draconic month. So let's define them. First, the synodic month, the time between 2 successive new moons corresponding to the moon's orbital period relative to the sun. What that means in reality is the luminosity of the moon, which is directly correlative to the sun's position, right? Because the further the sun gets away from the moon, the brighter its luminosity becomes. The closer the moon gets to the sun, the lesser its illumination becomes, right? So the synodic month is a timing of this periodicity. Its mean length is something like 29.53 days. The animalastic month is the interval between two successive passages of the moon through perigee, right? Remember, in an elliptical orbit has perigee and apogee, perigee being the closest, apogee being the furthest point in its cycle. The animalastic month then is the interval between two successive passages of the moon through its closest point. And then its mean length is 27.55 days. Then you have the draconic month, which is the period between two consecutive passages of the moon through the same orbital node. So remember we talked about Rahu and Ketu in the lunar nodes. Well, this periodicity describes the time it takes for the moon to go from one node and then all the way back through the same node again and again. The mean average is 27.21 days. Notice they're all close, but all a little bit different, and they do line up ultimately. So let's break up what makes up an actual Saros cycle. Well, within the Saros cycle, you have, again, the synodic, draconic, and animalastic month. So again, synodic, moon returns to the same phase. Draconic, moon aligns with the same node. Animalastic, moon returns to perigee, the closest point. After one Saros cycle, or lunar cycle, to 18.03 years, these three inner periodicities realign almost perfectly, creating similar eclipse conditions. So, the lunar cycle is 18 years, 10 or 11 days, and 8 hours. Now, why? Why is it that long? Well, it's 6,585.32 days, or 223 synodic months, or 242 draconic months, 239 animalastic months. The extra 10 to 11 days account for the lunar distance around the Earth, and the 8-hour offset means that eclipses in Saros series shift westward by about 120 degrees longitude between each cycle. Now, longitude, of course, having to do with time, because the hour angle transformation to convert longitude to right ascension just means 4 minutes per degree, meaning that it's just the time component of the celestial system, which equates to the longitude, which is the angular separation on the graticule. So it is this 8-hour offset actually that determines the shift. If it was not for this 8 hours, the eclipse would occur exactly where it did before, and we'd have an ever repeating cycle. Because of this shift, it means it occurs at a slightly different place each time, and that is what sets off the cycle. And that means that it's happening in a different spot in the zodiac each time, and its track around the cycle will create the greater celestial cycle that we're talking about. Right, so it depends on whether the first eclipse of the series occurs east of a rising or a falling node, and which of the two nodes that the moon is crossing when it's on the ecliptic. And that determines the direction in which it shifts by 120 degrees, right? So it takes about 18 years for the teams of eclipses that make up this cycle to make a 360 around our realm. That is its cycle, right? So the 651 or 649 great astronomical year is a 2-revolution cycle. It's got 2 revolutions of one cycle of 325 years, and then another cycle of 326 years alternating. And of course, each one of these has 18 times 70, which would be 1,261 eclipses in each cycle, pairing, or Saros cycle. After one Saros, the moon will have completed roughly a whole number amount of synodic, draconic, and animalastic periods, and the sun-moon geometry will be nearly identical. That means the moon will be in the same phase, at the same node, and it'll be from the same distance at the same spot, almost. So the same eclipse happens every 18 years for a total of 36 times in 651 years.
Right, so again, the difference between what we're going to be looking at with Saros is the Saros happens every 18 years, 11 months, and 8 hours, right? Because if you look at this one, this is an eclipse that gets mirrored over here, that gets mirrored over here. This is the same eclipse as this eclipse, but it's happening a third of the way around the world, right? This is in 2117, this is in 2135, this is in 2153. So this is what they're talking about. And this is how they number Saros series. And that's how Saros series go for hundreds and thousands of years, and how it gets super confusing because each one of these will be the same lunar eclipse over and over, and it will run out and run out and run out in perpetuity. And then they'll do the same thing with say a total annular solar or a total solar. And then that will repeat and repeat and repeat and ad infinitum. And that's like the most disjointed, disharmonic way to characterize the cycles in the sky that I can think of, right? It's ridiculous. So again, with the main point of that though is that there's an offset 120 degrees depending on where the intersection occurs, and that's what determines this bigger cycle that we're going to look at. So again, the longitude component in that 8 hours is crucial, right? Because if we have a sidereal rotation of the stars over flat Earth at 15 degrees per hour, which we know we have, and we can measure, and which interferometry all throughout time has confirmed, and which GPS's range and measurement equation depends on exclusively to make precise distance equations and precise distance measurements right now as we're talking. But if we were to think about what that 8 hours means, right? If the same eclipse occurs here and then here and then here, that would be great, right? We'd be able to predict that. But what's happening is it's having an offset, right? Because of the rotation, because it's 8 hours, it's a third of the way around the world. The longitude, or the time component of the celestial sphere, has moved it and placed it over here. So what used to happen over here now happens over here, right? That's the basic idea. We're going to go through and sort of graph out one entire series of eclipses. So we looked at 70 eclipses in order. That's what one of these cycles actually is. It's one cycle of 70 eclipses that occur 2 to 3 every year. But we're going to graph them out real quick so we can get a visual grasp on how the sidereal rotation can space them out, right? So here's a cut and paste team of eclipse cycles. So you have your first two, right? The first two that occur. Again, these would be eclipses occurring in the same year in chronological order as we go forward, right? So the first two, you get a couple more. And then, of course, the stars are still moving, and we get a couple more. And, of course, we got this whole rotation, and then we have a couple more. And eventually, they're rotating around the Earth like this. So the stars are moving right around. And our team of eclipses at the intersection points is now moving backwards, processing backwards through the chronological time that we were looking at before. Something like this, right? So as the stars rotate around the Earth, the intersection points of these marked 70 intersections processes around the zodiac, right? And because each one of these gets a drift, they occur 36 times before it drifts off. So if we were to plot it out real quick in one little animation, we could do one whole series, right? This is the analemma from every position within the tropics. We're going to plan out a whole series, right? So we got first two, the next two, 3 that year, moving right along. This team, that intersection point, this grouping happens, and this grouping, right? 9, 10, 11, 12, this grouping, another 13. Right? So 18, it just keeps repeating and repeating and repeating. So that's how we're going to be looking at the chronology of it later. But real quick, let's satisfy our heliocentric lads' urges, because I'm sure that they're saying NASA predicts eclipses. Only NASA and geometry with space rocks and Newton's gravitation can predict eclipses. You can't actually do anything without it. You need NASA, right? So let's touch on that real quick, because this is my favorite part, is that NASA has nothing to do with eclipse predictions. Not a thing, not one thing. Matter of fact, they're so scared of it, they farmed out all their credibility, all their work, all their citations, and all their actual accreditation to this dude named Fred. Thanks, Fred. His name is Fred Espenak. Right? He works for NASA just like someone who's on sabbatical works for the dean at college, right? This dude got paid once, did some lectures, and now he does his own thing, but he's cited on every NASA site as the man who produced all the eclipses, right? He is the only one with the knowledge. He has the magic that can predict eclipses, and he's done it all what he's really done is produced a whole bunch of maps for all of what's known as the canon of eclipses. He has his book called the 5 Millennium Canon, but it's based on older canons which have existed from the French from all sorts of antiquity, and we'll go through how funny that is. But we look at real quick his blurb, right? His Espenak. He co-authored 5 Millennium Canon of solar eclipses and 5 Millennium Canon of lunar eclipses. Again, solar and lunar split up, and they catalog every solar and lunar eclipse from 2000 BC to the year 3000, 5,000 years of eclipses. Notice how we only need 5,000 years of eclipses. That's all of the eclipses that have ever happened. Almost, right? We're at year 6,025, so we have almost all eclipses. So, publicly saying, marking the first comprehensive, publicly accessible records of their kind. Prior to this, no single source provided such extensive, mathematically precise eclipse data. Now, there were there were books, right? There's something called the Canon of Eclipses from 1887. There's a compilation of 13,000 solar and lunar eclipses. So wait a second. This existed in 1887, well before NASA, well before Fred. But Fred is accredited over here with the most comprehensive work of spanning 5,000 years of eclipses. Okay. But this already exists. I mean, it says all solar and lunar eclipses between 1208 BC to 2161. So one could argue that there's a pattern here, right, that you could extract and then extrapolate. And also,
this is Opposer's Canon of Eclipses.
There's this video about it.
1887 is the publication date. It has 8,000 eclipses computed in tabular form. My favorite part is in the back, though. We have these really cool maps of eclipse paths. And if we flip to this page is all the eclipses from 2008 to 2030. And if we look really carefully over here, we can see it says 4 in Roman numerals, which is April 8th, 2024, and there is the path.
So this book from 1800s had all of the data that Fred's book has, right? So if we look at the columns, it is in a different language, but with some AI, we can figure out, oh, look, they're talking about all of the same eclipse data that Fred published in his book is actually present in this much older book. And then this book, of course, is actually a copy of a much older book, which is actually a copy of all the ancient cycles. Because what Fred was famous for was going to all the ancient groups and ancient societies and looking down and marking down their calendars. And he was taking a look at their lunar, solar, and lunar calendars. And he made trips around the whole world and saw a bunch of eclipses. And what he was really doing was collecting all the cyclical data and then publishing it for NASA with a bunch of pretty maps. But this is the same data, right? You can even see Latin long over here, which is what you can argue is the only portion that for globularity, right? Which we can argue that all day, based on the hemispherical sky, and the hemispheric coordinate system, of course, based on celestial positions, is based on what we observe in a hemispherical sky and has no time to the shape of the Earth as a sphere. Steve, what's up, Steve? Any questions or anything so far? Went through a lot. All right, moving right along then. This is the canon that we're talking about from 1800s, and it has, in this column, we have the centrality of the eclipse, which is what you need to do predictions, right? It's got subcolumns at sunrise, at noon, and at sunset. So it's got sun, azimuth, and elevation angles. And then it's got longitude, latitude, and degrees. So literally, if we look at what Fred has, it's remarkably similar. So here's the 5 million canon of solar eclipses and the 5 million canon of lunar eclipses. I put the solar twice. Gotta fix that. It's supposed to be lunar and solar. He's got the one book of each, but the data is the same no matter what. It's exactly the same, and it's in the same order as over here. And if we want to break it down, it's on my spreadsheet over here. What you would need for predict eclipses is pretty much everything you have here, right? Sequential identifier. You don't even need the canon plate. You do need the calendar date, but that's how we spent so much time on calendars, trying to figure out how to make sense of that calendar date. The time of the greatest eclipse, which is in terrestrial dynamic time, we'll go over the delta T and what that means. The technical eclipse parameters. So this is the difference in terrestrial time. You have the lunar number, the Saros number, the type, which is definitely important, whether it's a total, annular, or partial. And then you have a qualifier, which is something like for the eclipse geometry. So the magnitude is probably the bigger one, the fraction of the sun's diameter covered by the moon, and that gets represented in an integer format. So the only information that you need really is displayed not only in all of Fred's information over here, but also in this old book over here. So all the same data from way before Fred and way before NASA has already been published in books and works of art. So we talked a little bit about delta T. What delta T is this big problem for eclipse predictions, and it's going to be the basis of our attack into chronology, right? This time problem, the constant rate of time of the sun and the moon, which isn't constant, it turns out. They call it terrestrial dynamic time. So it's a scale based on the oscillation rate of cesium atoms, right? Which we know is how atomic clock runs. That runs at a constant rate. So it's a difference between this form of timekeeping and then universal time, which is sidereal rotation time, which apparently gradually slowing down and has irregular fluctuations, especially when calculated over great periods of time. So Fred Espenak is famous for saying, hey, he has made his changes for predictions, including this change in delta T, meaning that he reduced it from an uncertainty to a certainty with gradations of 203 seconds, right? It's such a huge difference that the change in the sidereal time between 2,000 years is off 203 seconds. And that's what he's trying to correct with his eclipse prediction. So we'll go into delta T later a lot. I'm going to use it when Flamingo uses it to notice a discrepancy in the timeline. But for right now, it's only the difference between these two, right? It's just the difference between terrestrial dynamic time and terrestrial time, or universal time, or the time that a clock keeps and the time of the stars. That's the difference. And because the time of the stars is not constant, it causes problems. Interesting stuff, because you think it'd be constant. But over the longer amount of time that passes, the more variety and irregularity there is. So back to our book for all past time from our boy Dimbleby. Now we already mapped out 36 eclipses in a section. That was our movie with our video over there, which 18 years ends up being 648 years. So we're going to go through how our boy Dimbleby is going to reference the canon of eclipses, the lunar cycle, the old Egyptian and Babylonian and Hebrew lunar calendar, and we're going to date the world. He's going to use, he said he published his eclipse cycle of 651 years to work with both solar and lunar eclipses. So, I mean, it'd be weird if you just had solar and lunar eclipses separate. I don't know how you'd make any predictions or do anything that way, but his form uses both, right? And again, this is the depiction of how they would intersect and repeat. And he says, all past years by eclipses, by the recent great advancement of the science of astronomy, now we have obtained 6 astronomical lines of time based upon natural and scientific years by which all past years are known and consecutively identified. So he's saying he has 5 corroborative ways to date the world. Yeah, way more reliable than carbon dating dinosaur bones, giant steps of evolution with small minute changes of micro adaptations over billions of years to create the Big Bang and abiogenesis and life from nothing all at once. Or then we have this 6 lines of time that align concisely to give us a precise dating of our world. So he uses that, and he says the use of natural years and the use of intercalary periods, which we went over before, is how he's going to use this to repeat after his 649 year cycle. So he has a cycle which varies between 649 and 651 years. Like I said, it oscillates in between. And his basic argument is a team of 70 eclipses in lines and numbers occurring every 18 years. And the consecutive teams show their repetition. And we're going to go through that extensively. But the basic premise here, right, and he has a glober, so he's using the globular diagram of eclipses. But he goes through how he's going to use this as the date of creation, right? He's going to trace it back to 0. He's going to trace all of the cycles basing, he's going to use the 5 astronomical lines of time to trace the time back to 0. So we have a year 0, the date of creation, right? And he's going to say that's the first solar eclipse. And from there, you can start the first of the cycle. And then from which you can spin out all the rest of the cycles that have ever repeated. Here's a page 122 from his book. So he's got the small cycle of 18 years, the bigger cycle of 649 years, which is 36 of these cycles. And then he's also got this big maximum cycle for 5,841 years, 18 revolutions of the smaller cycle over here. But what he's really done is he's just made the data which he wrote the book, the last cycle, and said that all years would repeat like that. This is the main building block, and this is the one that oscillates with the 8-hour rotation. So 18 years, 10 days, and 8 hours. Don't forget the 8 hours when number 1 again occurs. So this is the chronometer with which he gets this. And he uses this gauge, which again, to prove all past time, using central eclipses, that uses intercalary days inserted into the Bible based on the Hebrew calendar. He uses transits of Venus, and then the solar calendar, the lunar cycle, and the eclipse cycle. Those are 5 different ways to corroborate this exact gauge. And at the time that he wrote this, which is 1861, he had concluded that all of the cycles in the sky added up to 5,861 years, which is what he was talking about over here. Right? He said this, he called this one giant cycle of this. But at the time he wrote it, it'd only been one of these cycles. So according to everything in the sky, all the eclipses that you can possibly detail, then there's only been 5,861 years of eclipses by 1861. Now that would put the year, something like 6,025 would be this year, right? So the structure of the cycle is he uses the lunar-solar synchronization, which is 7 metonic cycles, which we talked about earlier, which is the 19-year cycle of the lunar cycle to match up with the solar cycle and reconcile with intercalary days. So we also uses how he uses the solar cycle, planetary transits, and biblical chronology. So the 5 astronomical lines of time are corroborative on these lines: biblical chronology, planetary transits, Mercury, Venus, solar cycles, and the lunar-solar synchronization. So the metonic cycle. All of these cycles add together to give us this, which gives us the gauge of all past time over here. So he does a huge favor here, and he went through his cycles, and he dated 2 complete sets of these cycles to actual biblical dates, and then he pointed them out in the Gregorian calendar so that we can synchronize all other calendars to them. This is where it gets a little bit tricky, but oh crap, man, I was muted.
I was hoping it wasn't just me.
Nobody told me.
Yeah, I was about to jump on and go, what the hell?
Crap, okay.
It was only about 20 seconds.
All right, it felt like a long time. I was like, I said a lot. All right. So this is Dimbleby chronologically dating one series of eclipses, and he uses 3 types of calendars to do it: the AD, the solar year, and the AM, right? So he's linking up with 3 types of chronological timekeeping, and he's using the date of these eclipses, and he's mapping them to all 3 calendars. He's also keeping note of the type, which we're going to get into, which is very important. An actual series repeats these types in order every time. NASA does not tell you that because they split it up into solar and lunar eclipses, but he's keeping track of total solar, total lunar, partial lunar. And very importantly, over here, he's breaking down that there are 70 eclipses in a team, which contribute to the team. They all occur within 18 years. All of the years are lunar, but made solar by intercalary months. So this is literally a lunar-solar calendar, which is what we started with. So we can understand that he's keeping time based on the moon, but keeping seasons based on the sun, and inserting intercalary days to keep track, and using those intercalary days coinciding with the Hebrew calendar in the Bible. So very solid work here. This is kind of how you have to do it. When I first got into eclipses and I tried to date eclipses, I gave up almost immediately because I realized how hard it was to translate between 6 different calendars, 2 types of transitions, and the interim switching between solar to lunar to count leap years. Which, like, there was so many variables that I immediately saw that it was impossible. I was like, there's no way I can do this. So to have someone be able to do it through all this work was huge. And from this, you can sync out all the other great eclipse cycles. So if you have one cycle chronologically dated, you can date the whole series, right? That's the whole point. And date them he did, right? So he has all of these eclipses here. We're going to go through them. Essentially, he has them dated to 1818 to, I forget the other one, but we'll go through the end of it. But he's got the first team over here, the second team over here. So this is the continuation of the first team and the second team. And again, first team is 70, second team is 70, right? So he's got them all dated and chronologically linked so that we know sequentially when they occur, what number they are, and in what date they occur. And here's the top one blown up, right? The ancient Hebrew bird's eye view of the team of 70 eclipses occurring every 18 natural years. Right, so 18. So he's got all this mapped out. This was the bottom half. So he did confirm with his buddy George Airy, who we're familiar with. He says he's indebted to George Airy for when he was the Astronomer Royal, called my attention to some features in a French work. Oh, wait, isn't that what we just looked at? The art de verified less dates per eclipses. I didn't say that right at all, but it's another old canon for 1,262 periods of eclipses. No way. He said, so George Airy told our boy Dimbleby, hey, there's a book of a canon of eclipses that links all the eclipse cycles that you're talking about, hooked them up at the Greenwich Observatory. And he said he met him there for supper at the west of London. And then he met a German work called the Canon of Eclipses, which we also looked at, which again is the 18 years of 223 lunations using the calendar kept by Babylonians and Egyptians and etc. And from these eccentric works, he said he published another eclipse cycle, the 651-year cycle. But it's to work with both the solar eclipses, right? So we went over that before, but this is him putting forth, hey, I'm aware of everything that came before me, and here's my contribution to it, clearly. To compare and contrast with Fred Espenack, who said he alone has created and dated all eclipses by himself. Hail NASA. So this is him just going through the distinctions between the dating standards that he's using, intercalary days, the sequential 7-day week, and the lunar year and the solar year. But I think we went over that a lot. And again, he's noting here by use of the Metonic cycle, which again is how you synchronize lunar and solar calendars with the every 19 years. This is the antediluvian solar cycle, and the two meet after 133 years, and he dates it back to a Sunday. So his whole dating chronology, of course, is using the times and genealogy of the Bible, the 7-day week over here, to link it back to the first day of creation. So he said it starts with Sunday, which then links to the rest of the eclipses, and he's got a new moon over here. Right, so new moon starts the month as he started off earlier, and that's how we know. So we showed this diagram a bunch. So this is one team of eclipses that we looked at earlier. So number 1 through 36 we looked at graphed out, and this is one complete cycle, right? So 35 and then 36. We have 70 over here. What we don't get told, though, is that this repeats all the time. So here's the symbols. We have this for a solar, or a total, this for a partial solar, this for a total lunar, this for a partial lunar. And if you look at how each one of these series starts and how it goes, every series will occur in the same order. And that to me is crazy. Crazy that people don't know, crazy that it happens that way, and crazy that, it literally is that dependable. So if we look at over here, this one is number 1 and the 2 are partial solars, and then number 3 is a partial lunar, number 4 is a partial solar, number 5 is a total lunar. And if we look at the dating of these, it's the same. It's the same every time. So here we have 2 different Saros series, and again, don't get confused. These are the long drawn out series, all right? But we're going to have two together, series 9 and 10, and they're going to be identical, right? Each line for line, each number is the same. Every 17th is a partial lunar, right? Every 21st is a total lunar. And that happens all the way through the series. And that's how you know the time and manner repeats. When we went over the repetition of the synodic and draconic and animalistic months, we said the character of eclipses will be the same. Now, don't forget, this is happening all throughout our realm. Actually, here, this is a better diagram, right? If it happens, one eclipse happens here, 18 years later, it happens over here. 18 years, it happens over here, and then over here, and then over here. And if you imagine this as a rotating zodiac of stars around the realm, right, then it would occur at the same time, but a different offset, right? So that 8-hour offset puts it a little bit off, a little bit off, a little bit off. And that's how you have a whole repeating cycle of 651 years. The 18-year, 10-month, and 11-day cycle repeats 36 times, which then repeats for a total of 70 eclipses all the way through, right? And if we were to graph them out, it would look a lot like that. But this is the same eclipse happens every 18 years for a total of 36 times in 651 years. So again, think about this as the zodiac, and this wheel would represent this character of eclipse repeating and repeating and repeating and repeating and repeating and repeating around the wheel of time, which is the wheel that we started with in the beginning. If you remember, see if I can get back to that, because it's such a good example of the cyclical nature of time represented with the inner and outer wheels, which so accurately imbibe the themes that we're talking about here with the intercalary offset of the solar and lunar calendars, because the Gregorian calendar sort of has them all outlined together, right? So we have the lunar phases, the seasons and the months around the outer side, the days of the month, the constellations, and you even have the progression of the sun, right? That's what the sun wheel's for. So they have it all, and they were really kind of keeping track of everything. And I think that our calendars today are not sort of woefully incompetent, right? They're not, by accident, not keeping track of the cycles. They didn't accidentally split up the lunar and solar canons into completely separate books. It was absolutely on purpose and intentionally to obfuscate, so that you won't be able to keep track of the time, so that you'll be disconnected and and live in disharmony from the cycles in the sky. But again, if we were to look at this, they repeat by character every time, right? So this one is the same as this one. Every series has 2 partial solars, a partial lunar, a partial solar, partial lunar, partial solar, total lunar, all the way through. And that character repeats every time. So again, the 5 astronomical lines of time that we're going through here to date the whole world: the lunar cycle, the solar cycle, he called it the Vox Day, but it's the eclipse chronometer, right, with the whole eclipse line of time that we're going through, and the transits of the wandering stars. So we're not going to go into it, but there's a lot more detail that goes into the transits of Venus. It too has varying teams that go through the same periods. He's identified that they occur in a period of 486 years, and he says that a transit happens of the same character and numer in each team, produced by the following intervals. So he's done the same thing for the outline of the transits of Venus. He has the same chronological dating with the same method, which coincides with our previous chronometer. And he has the fifth line of time doing the transits of Mercury, and again, the same way, saying that he has the same team-like repetition and that they coincide with the other lines of time. So these are 5 lines of corroborative time that all point to the same dates, that all link back to the day of creation, that all tell us that we are in the year 6028, right? Or 6029, depending if you count the first as 0 or 1. Using the eclipse chronometer, right, you can tell all the cycles that have ever been back from the first day, lining up with all the lines of time through the historical chronological dates of the Bible, through the transits of the planets, through the solar cycle, and through the lunar cycle, all coincide on this date, and they all make it so that this year, 2025, would be the 6028th year. There's also a video I found back from an old Bible that sort of says the exact same thing.
This Bible from 1813 has something very interesting.
If you ignore the Harry Potter
It is
music,
a facts page that contains a list of people and events in chronological order. It says, whereupon we reckon that from Adam unto Christ are 3,947 years, 6 months and 10 days. And from the birth of Christ to this present year is 1814 years. Then the whole sum and number of years, from the beginning of the world unto this present year is 5,788, 6 months, and the said odd is...
Right, so that sort of says the exact same thing. If that book was published 25 years ago and then reprinted in 1813, that would make it 6,000, the year 6029 exactly. So that's just using the same sort of chronology that we would use to get an outside measurement, right? So what if all the Bibles before 1850 came with a complete chronology of the world? Like, I don't know, maybe that was a thing. Maybe all the books knew what year it was, and now, once they got rid of them, now they can just lie. It would be very easy to lie about how many years there have been. I know that my opinion is that they need to lie, right? Their lies need billions of years. Evolution needs a bajillion years. The birth of the planet of Earth needs 13 billion years. The coalescence of gases through galactic accretion to create planets needs 13 billion years. The lunar theory of how the moon got here needs billions of years to coalesce, to get the impact theory to recoalesce, the dinosaurs to evolve, for the comet to hit, for humans to evolve out of fish, frog, monkey, and crow. All of that needs all this time. None of that makes sense if the world is 6,000 years old. None of it makes sense. But this was the first thing that had to go for all those heliocentric lies to take shape, in my opinion. And we have our boy, The Issue with Chronology, done by Flamenco, who has a series of 10 to 12 books, I think, who did some work with the chronologies of specific pasts. And he noticed a lot of discrepancies with how they were dating things. And lo and behold, he used the eclipse cycle and that delta T to do it. So here's a bunch of quotes that I think he put in his book that I think are great. History is a pack of lies about events that never happened, told by people who weren't there. Love that one. And then this one is probably my favorite, by George Orwell. Who controls the past controls the future, and who controls the present controls the past. So there's a lot of power in lying to a civilization about how old they are so that you can control their mind and tell them all sorts of lies. But Flamenco's basic premise is that the dates provided in the historical record are faulty and that they don't coincide with what he called the coefficient D in the theory of lunar motion. But what it really is the time function on a large historical interval. So if we remember, we were talking about delta T and terrestrial time and the difference between that and universal time, or the time of atomic clocks and clocks and timekeeping versus sidereal rotation. There's a discrepancy in that over a long period of time it was only 203 seconds. But his notice was that there was actually a large leap and a gap, right? So what he says is there are insertions of 1,000 years or more into the historical record, and that you can see this, and it's evident in the fluctuation of his time interval when eclipse cycles are assigned. So I'm not going to go into Flamenco too much. This is already a super long presentation, and he's wrote like 13 books on this. I've read one book on it. I've read this. This is the first one, and it's super dense. It goes into many, many topics. He has many corroborative tales. He has a whole theory on the historicity of Rome and how that was actually improperly dated, which would coincide with the insertion of 1,000 years from the old Tartaria record, from the old buildings with the years scraped off to seeming like K turned into C or something. All of that would coincide as well, but we're not going to go into that too much. Just know that they describe the same period of history for different dynasties. That's one of his astronomical lines of time, is the dating of dynasties between civilizations. And he comes out with the same conclusion that, hey, there's a drop rate in the lunar acceleration parameter, and that these combination of the angular accelerations ascribe to astronomical inconsistencies beginning around AD 1000. So if you date the historical record of not just our civilization, but he goes across to every civilization, and there's always this gap beginning of 1,000 years. based on the lunar periodicities and the time component, or known as delta T, and the eclipse cycles when using that to combine with dating. So again, the main point is that you can use the eclipse cycles, which are chronologically repetitive and easily identifiable, right, to anyone who can look at the sky. And then you can use that to date the world based on eclipse cycles back to the year 1, which would make it the year 6029, right? So that's pretty much it, guys. There's a whole bunch, but we got a lot of detail, a lot of maps, a lot of visuals. What do you guys think?
Well, it's a pretty complete set of slides, man. Right on.